You look in a mirror every single day. You brush your teeth, you comb your hair, you check if there's spinach stuck somewhere embarrassing. You've done this thousands of times, tens of thousands of times. And every single time, something very strange happens that you've completely accepted without question. Your reflection raises its left hand when you raise your right. The writing on your shirt appears backwards. The mole on your right cheek shows up on the left side of your reflection's face. The mirror flips everything left to right. Obviously, everyone knows this. You learned it as a child and never thought about it again. But here's the thing. It's wrong. Completely, utterly, fundamentally wrong. The mirror does not flip left and right. It never has. It never will. It cannot. And when you understand why, when you really grasp what's actually happening when light bounces off that silvered glass, you'll realize that you've been fooled by your own brain your entire life. Not by the mirror, by yourself. And that's far more interesting than any simple optical trick. Let me show you something. Stand in front of a mirror right now if you can. If you can't, just picture it clearly. You're facing the mirror. Raise your right hand. Your reflection raises its left hand. That's the flip, right? Left becomes right, right becomes left. Case closed. But wait, why doesn't the mirror flip you upside down? Your head is still at the top. Your feet are still at the bottom. Up stayed up, down stayed down. But left became right. Why would a mirror discriminate? Why would it flip you horizontally, but not vertically? What's so special about the horizontal axis? Think about this for a moment, because it's a genuine puzzle. If mirrors flip things, why do they only flip in one direction? Why not the other? The answer is that they don't flip left and right at all. That's the wrong way to think about it entirely. The mirror does flip something, but it's not what you think. And understanding what it actually flips changes everything about how you see reflection, symmetry, and even how your own mind constructs reality. Here's what's really happening. The mirror flips you front to back, not left to right, front to back. It reverses the axis that points into the mirror and out of the mirror. That's the only axis it reverses, the only one. When you stand facing a mirror, you have three directions you can move. You can go left or right, that's one axis. You can go up or down, that's the second axis. And you can go forward toward the mirror or backward away from it, that's the third axis. The mirror only reverses that third axis, the forward and backward one, the depth axis. It takes whatever is pointing toward the mirror and makes it point away from the mirror in the reflection. That's it. That's all a mirror does. Left stays left. Right stays right. Up stays up. Down stays down. Only front becomes back and back becomes front. So why does it look like your left and right are flipped? Because you're confusing yourself. You're doing something in your mind without realizing it, and that mental operation is what creates the illusion of left-right reversal. Let me walk you through it very carefully. You're standing in front of a mirror. Your right hand is on your right side. In the mirror, your reflection's hand that corresponds to your right hand is also on the right side of the mirror. Think about this. If you raise your right hand, and it's on the eastern side of the room, the reflection's corresponding hand is also on the eastern side of the mirror's image. The hand hasn't moved to the other side. It's in the same position relative to the room, relative to the mirror, relative to everything external. The mirror didn't move anything from left to right. But here's where your brain betrays you. When you look at your reflection, you don't just see an image. You interpret it. You imagine that the reflection is another person facing you. And if it's a person facing you, then that person's right side would be on your left. You mentally rotate the image. You spin it around in your head, 180 degrees around the vertical axis, to make sense of it as a person facing you. And when you do that rotation in your mind, you flip left and right. Not the mirror, you. The mirror just sits there innocently reflecting light. It's your brain that takes the image and says, if I were to walk around behind the mirror and turn around to face where I'm standing now, then my right hand would be on the other side. But you're not walking around behind the mirror. You're standing here. And the mirror isn't flipping anything horizontally. You are. Instead of standing in front of a mirror like a normal person, try lying down on your side. Does the mirror still flip left and right? The mirror is still doing exactly what it always does. Reversing front and back, but now your left-right axis has become the vertical axis from the mirror's perspective. Does your head appear where your feet should be? No. The mirror doesn't flip you based on your orientation. It doesn't know what left and right mean to you. It doesn't care. It just reverses the axis perpendicular to its surface. That's physics. The so-called left-right flip is your interpretation, not the mirror's action. Try another experiment. Don't look at yourself at all. The text appears backwards, reversed, flipped, left to right, it seems. You flipped it. When you turned the page to show it to the mirror, you rotated it around the vertical axis. You kept the top at the top and the bottom at the bottom, but you swapped left and right as you turned it. The mirror had nothing to do with that. You did that yourself, with your hands, before the light ever touched the mirror. The mirror just reflects what you showed it, a page that you had already turned around. If you want to test this, try turning the page by flipping it around the horizontal axis instead. Keep the left edge on the left and the right edge on the right, but flip the top to the bottom. Now look at it in the mirror. The text is upside down in the mirror, not left-right reversed. Still unreadable, but differently unreadable. The mirror treated both cases exactly the same way. The difference was in how you turned the page before showing it to the mirror. You created the apparent reversal by your choice of rotation. The mirror is innocent. Here's the deep principle. A mirror doesn't know anything about left and right. How could it? Left and right aren't properties of physics. They're properties of perspective. My left is your right if we're facing each other. Left and right depend on which way you're facing. They're relative to the orientation of the observer. But a mirror doesn't have an orientation. It's just a flat surface. It doesn't face left or face right. It has a front and a back, and it reflects light off the front. That's all. The front and back are the only directions that have any meaning to a mirror. And those are exactly the directions that get reversed. Not because the mirror chooses to reverse them, but because that's geometrically what reflection means. Light comes in from the front, bounces back, goes out to the front again. The rays that were traveling toward the mirror are now traveling away from it. That's front-back reversal. Pure geometry. So why do we say mirrors flip left and right? Why does everyone say it? Why does it feel so obviously true? Because human beings are approximately bilaterally symmetric. We have a left side and a right side that are nearly identical, and we stand upright. We don't lie on our sides or our backs when we look in mirrors. We stand with our head up and our feet down, facing forward. And when we see a human figure facing us, our brain has decades of experience interpreting that figure. We know that when we're face to face with another person, the right side is on our left. We've had millions of interactions that trained us to automatically perform this mental rotation. When you look at your reflection, your brain doesn't see it as a light reversed image of yourself. It sees it as another person facing you. And it applies all the rules it learned about facing people. It expects the other person's right hand to be on your left side, but it isn't. The reflection's right hand is on your right side, the same side as your actual right hand. And so you conclude that left and right must be flipped. But they aren't flipped. The hand is in the same position. You just expected it to be somewhere else because you mentally turned the image into a person facing you, which it isn't. It's you seen from in front, with front and back reversed. Not rotated, reversed. Think about a simpler object, one without bilateral symmetry. A sphere, maybe. Put a sphere in front of a mirror. Does the reflection look flipped left to right? How would you even tell? It's a sphere. It looks the same from every direction. What about a cone? Stand a cone in front of a mirror with its point facing up. The reflection has its point facing up too. No vertical flip. Now turn the cone so the point faces right. The reflection's point also faces right, not left, right, the same direction. No horizontal flip. Now turn the cone so the point faces toward the mirror. The reflection's point faces toward you, out of the mirror, toward where you're standing. The point was going into the mirror. In the reflection, it comes out of the mirror. Front became back. That's the only thing that changed. The sphere, the cone, they don't have a hand in this problem. They don't have a left or right. There's nothing to flip. But you are different. You have a handedness. You have features that distinguish your left side from your right side. And more importantly, you have a face. You have a front. When you face the mirror, your front is toward the mirror, and in the reflection, the front is toward you. Front became back. Your face, which looks out of your front, now appears to be looking out of the back of where you would be if you walked into the mirror. And because you imagine yourself walking into the mirror and turning around, which would require rotation, you attribute the left-right difference to the mirror. But it's not the mirror. It's the imaginary turning around that you added in your head. Here's another way to think about it. Imagine the mirror is a magic window, and there really is another room on the other side, an exact copy of your room. And in that room, there's a person who looks exactly like you, standing in the same position, wearing the same clothes, making the same gestures, in real time. But this person isn't a copy of you. This person is you, but with front and back reversed. Their chest is where your back would be. Their face is where the back of your head would be. If you could somehow reach through the mirror and shake hands with this person, you would both have to reach forward, toward each other. And when your right hand met their corresponding hand, it would look like it's on the wrong side, because this person isn't facing you. This person is oriented the same way you are, but reversed through the mirror. If you both walked forward, you would walk toward each other. But their forward is where your forward is, just reflected. It's the reflection that creates the apparent reversal, not any rotation. Now let me tell you why this matters. Why spend all this time on what seems like a trick of perception? Because this simple puzzle about mirrors reveals something profound about how we construct reality. We see the world as our brain interprets it to be. And sometimes, those interpretations are so automatic, so ingrained, so invisible, that we mistake them for facts about the external world. We say the mirror flips left and right, as if that's a property of mirrors. But it's not. It's a property of how human brains interpret images of human bodies. The mirror does exactly what physics says it should do, reverse the direction perpendicular to its surface. The left-right flip is added by us, by our mental model of what a facing person should look like. This happens everywhere, not just with mirrors. We see optical illusions, and we think the illusion is out there in the world, when really it's in the interpretation. We see the sun rise and set, and we say the sun moves across the sky, when really we're moving. We feel the ground is stationary, and the stars is spinning around us, when really it's the opposite. Perception is not reality. Perception is a model of reality, built by a brain that evolved to survive, not to accurately represent the physics of the universe. And most of the time, the model is good enough. But sometimes, like with mirrors, the model breaks in interesting ways, and we can learn something by looking at those breakages. Let's go deeper. Why does the mirror reverse front and back in the first place? What is reflection, really? When light hits a mirror, each ray of light bounces off. The angle at which it bounces is equal to the angle at which it arrived, on the opposite side of the perpendicular to the surface. This is the law of reflection. Light that came from in front of the mirror arrives at your eye as if it came from behind the mirror. That's why you see an image behind the mirror. The image appears to be at the same distance behind the mirror as the object is in front of it. Your brain interprets light rays as having traveled in straight lines from their source, so it places the source of the rays behind the mirror. That virtual image is exactly like the real scene, except that everything that was toward the mirror is now away from it. Front became back, but here's something subtle. The light didn't actually go behind the mirror. The light bounced. It stayed on this side of the mirror the whole time. It's just that when it enters your eye, the angles are such that it seems to have come from behind. Your brain creates the image. The image isn't there, behind the glass. There's no ghost of you standing in the wall. The mirror is a trick of geometry, and your visual system completes the trick by constructing a three-dimensional interpretation of the incoming light. A corner mirror. Something very strange. You see yourself as others see you, not mirror reversed. True left. Two front back. The first mirror flips front to back. The second mirror flips the new front to back again, which is now back to front, undoing the first flip. And because you're seeing yourself without the front-back reversal, and because your brain no longer needs to do the mental rotation to make sense of it, suddenly left and right are where you expect them to be. No conflict. No apparent flip. This proves that the original single mirror flip was never about left and right. It was always about front and back. Remove the front-back reversal, and the left-right puzzle vanishes. You can also think about this in terms of coordinate systems. If you set up a mathematical coordinate system with x pointing right, then after reflection, x still points right, y still points up, but z now points away from the mirror. Only one coordinate changed sign. That's the math. Not 2, not 0. The depth axis. And mathematically, reversing one axis creates what we call a reflection or a mirror image. It changes the handedness of the coordinate system. A right-handed coordinate system becomes left-handed. That's where the chirality comes in, the handedness. But it's not about left and right as directions. It's about the handedness of the entire coordinate system. If you had a three-dimensional model of yourself, say a detailed sculpture, this is deeply connected to why some molecules can't be superimposed on their mirror images. Reflection changes handedness, but the axis that gets reversed is always perpendicular to the mirror, not parallel to it. So the next time someone asks you why mirrors flip left and right, you can tell them the truth. Mirrors don't flip left and right. They flip front and back. We mentally rotate the image and then blame the mirror for the consequences of our own mental rotation. The mirror is doing exactly what it should, exactly what physics requires, reflecting light with front-back reversal. The rest is psychology. Mirrors don't flip left and right. It teaches you that your intuitions can be systematically wrong. It teaches you that the obvious explanation isn't always correct. It teaches you that sometimes you have to go back to basics. Think about what's really happening. Follow the logic wherever it leads, even if it contradicts what everyone knows to be true. Everyone knows mirrors flip left and right. Everyone is wrong, and that's beautiful. That's what understanding is. It's not memorizing facts. It's not accepting what you're told. It's seeing through the illusions, even the illusions created by your own mind. Because once you see through one illusion, you start wondering what other illusions you're living with. What other obvious things might be wrong? What other questions you've never asked because the answers seem too obvious to bother with? And that's where the real thinking begins. That's where science happens. Not in knowing the answers, but in questioning the questions. In realizing that sometimes the question itself is based on a false assumption, and the whole puzzle dissolves once you see what the assumption was. Mirrors don't flip left and right. They never did. The question was confused from the start. And now you know why. Now you see it. And once you see it, you can't unsee it. Every time you look in a mirror from now on, you'll know. The mirror is just reflecting light. You're the one doing the flipping. You always were.